Good day, great girls. A pleasant moment again. We are meeting in the discussion for geography in preparation for the March test. We are going to go through a sample paper, which is mainly based on our first topic, which is climate and weather, and also slightly some other aspects of geomorphology. So this is in preparation for the March test, and also in the long term in preparation for your junior exams paper 1. Remember, the first two topics are the topics for paper 1, theory, weather and climate topic number 1, and geomorphology, your topic number 2. But remember also in the March test, you are not going to be examined on map skills, since you would have done a separate task on map work. So it's only a theory that we're going to discuss here. We're going to use the sample questions that we have, and we're going to try to illustrate and try to explain where there's need, so that at least you have a clear understanding of how to approach the questions and also how best you can respond to the questions given. So as usual, remember, our paper is written in 1 hour, and it's a 60 mark paper. It's out of 60. So I'm going to go through the sample paper, and we're just going to discuss and also try to highlight the possible responses. Right. We start with our first question on climate and weather. The sketch that we have here, it's a sketch showing line thunderstorms over South Africa. Right. You must be able to interpret the sketch that we have here and be able to figure out the geographical sense of what is happening in the sketch here before you even answer the questions. So if you are looking at this sketch that we have here, we have our South Indian high pressure and our South Atlantic high pressure. And for the same reason, we are saying, because of these two high pressure cells, there is a tendency, our South Atlantic high pressure on the west and our South Indian on the east. There is a tendency of the air to circulate out of the high pressure cells, these anticyclones. Remember, our circulation is anti-clockwise when air is circulating out of the high pressure cell. So we tend to have air being driven out of the high pressure cell of the South Atlantic high and being fed into the interior, like what is indicated by these arrows. And again, we have another anti-clockwise circulation from the South Indian high pressure, which is feeding in air into the interior here. So we need to analyze the oceans, the two extreme oceans that we have. On the eastern part, remember, we're talking about the Indian Ocean. And on the western side, we're talking about the Atlantic Ocean. And for the same reasons, we are saying the Atlantic Ocean is dominated by the cold Benguela current. The movement of the water here is such that it comes from the colder region, the polar region. If you can check the arrow here, it shows that this motion here of this air is coming from the polar region going towards the equator. But if you look at the Mozambique current, it's coming from the equatorial region going further down. So for the same reason, this is a warm current and this is a cold current. So it means if these two anticyclones are feeding in air into the interior, this one is going to feed cold and dry air from this side. And this one is going to feed warm and moist air. And for the same reasons you are saying, these two air masses are going to meet somewhere along this line here. They are going to meet. The cold and dry air, which is being fed from the west, is meeting with the warm and moist air coming from the east. What is going to happen when these two air masses meet? There is going to be a front which is going to form here. There's going to be a boundary which is going to form. And along this boundary, the cold air, remember, cold air is denser. We are saying cold air is denser. And for that reason, that is denser, it means it is going to undercut. It's heavier. is going to undercut the warm air. And the warm air, remember, warm and moist air is less dense. And for the same reason, it is going to be uplifted. So when the two air masses meet along the front, the cold and dry air is going to undercut, the warm and moist is going to be forced to rise. And as a result, we have the moisture in this warm and moist air coming from the Indian Ocean is going to reach dew point, is going to condense, and is going to result in clouds. And these clouds are going to produce heavy rainfall, which is associated with thunderstorms. So for the same reason that on the eastern side is where we have the warm and moist air being fed in that direction, and we have cold and dry air being fed from the western side. So we experience rainfall on the eastern side of our moisture front. We experience rainfall on the eastern side here. And with time, we are saying our moisture front will gradually move in the eastern direction like that. The more the cold air is fed, is going to undercut and push warm air, and the moisture front is going to gradually shift towards the eastern direction. That's the basic understanding of what you must interpret from this interpretation of this sketch here. So let's go to answer our questions. We are just going to answer the questions quickly. The first question is saying, what does the line labeled A on the diagram represent? The line which is labeled A on the diagram. Whenever I'm talking about this line here, this blue line that I have indicated here, I have explained what kind of a line it is. It is called a moisture front. We call this a moisture front. Right. Then number 112, what causes the thunderstorms? Shown in the diagram. What causes the thunderstorms? The thunderstorms are caused by the interaction of cold, dry, with warm, moist air. Our response A. The interaction of these two air masses will result in the thunderstorms. Right. What type of weather is associated with the moisture front in the diagram? What type of weather? Right. If we look at the type of weather there, we tend to find that the weather that we're going to experience is typical weather with intense thunderstorms and rainfall. We call this a line, we call them line thunderstorms. They happen along the moisture front. On the eastern side of the moisture front, we have a series of thunderstorms being experienced there as a result of the interaction of the warm, moist air with the cold, dry air. We have heavy rainfall also because of the upliftment of warm and moist air from the South Indian anticyclone or high pressure cell. So for that same reason, it gives us heavy rainfall, and it also associated with intense thunderstorms. Right, we move on to the next question. It says thunderstorms are concentrated along the eastern side of the moisture front due to. We have just explained that the thunderstorms will be allocated in series along a line on the eastern side of the moisture front, for the reason that warm moist air from the Mozambique current is forced to rise along the escarpment. That's the reason. Right, we move on to the next question. Which statement best describes wind B? Which statement best describes wind B? Let's go out and look at our wind. This wind here, we have talked about that. What kind of wind is that? Which is coming from the Indian Ocean. So our wind here is warm, moist air. Warm and moist. Remember, warm air is the one that has got capacity to contain moisture. If air is warm, it has capacity to contain moisture. But if it's cold, it doesn't have the capacity to contain moisture. So in geographical sense, we are saying cold air is usually dry. And warm air, if it has chances of acquiring moisture, it will be warm and moist. Like this air coming over the Indian Ocean, remember the Indian Ocean is a warm ocean. So for that same reason, the air that comes over the warm ocean is going to carry with it moisture. So it is going to be warm and moist. While it's from the Atlantic Ocean, where there is a cold Benguela current, the air being fed from that extreme end is going to be cold and dry. And also remember about the density. Cold air is more denser, it's heavier than warm air, such that when the two air masses meet along a front, the cold air is going to undercut, is going to take space from the ground, while this warm air is being forced to rise, is going to ascend. That is what happens along the moisture front. Right, we move on to the next question. What conditions must exist for the moisture front to shift further westward? Right, let's go back and look at our question. Here we said the moisture front, it moves from the west going towards the east. It shifts to the east. But there are exceptional conditions. We are now saying what can facilitate the reversal of the ordinary movement direction for this front to move further to the west, to go back to the west. It means there must be an imbalance between these two air masses. We must have more air being fed from this side, which is going to deflect the direction of the cold air from the other end. So let's look at our responses and try to figure out what can be a possible reason that can result in the moisture front shifting further westwards. That can only happen if there is a stronger inflow of warm moist air from the east, which is D. If there is a stronger inflow from the east, it means it's going to drive the colder air from the Atlantic to the western side. And that is an exceptional conditions. Under normal conditions, our moisture front will drift eastwards. The moisture front is going to move towards the eastern direction. Right, that takes us to the end of the first part. Let's go to the next question. This question is based on tropical cyclone Becky. I'll just try to explain in simple ideas of the process of the formation and also how the tropical cyclones are realized on a geographical scale. Right. When we're talking of tropical cyclones, when we're looking at cyclonic weather systems, remember always when you talk of a cyclone in geography, we are referring to a low pressure system. So tropical cyclones, meaning to say these are low pressure weather systems which are realized within the tropical region. I understand you know the tropical region. When we're talking of the tropical regions, we are looking at the regions within the zone of the tropics, from the equator to plus or minus 30 degrees north and south. But also what you must note with the tropical cyclones, we said they do not effectively form within the 0 to 5 degrees of the equator. Between 0 to 5 degrees north or south of the equator, they don't effectively form tropical cyclones. Why don't they form in that belt? It's because of minimum Coriolis effect, or there is a minimum deflective effect in that zone of the equator to around 5 degrees to the north and to the south. And for that reason, we say Coriolis force is a basic requirement for the formation of tropical cyclones. They need that deflective effect for them to effectively form. So for the reason that the deflective frequency of our Coriolis force is almost 0% at the equator, and it increases as we go towards the polar regions. So it's very strong around the polar region and it's very weak on the equator. And for the same reason, that is why we're saying our tropical cyclones, they cannot effectively form within the belt of 0 to 5 north and south of the equator. Right, that is what the basic thing that you must also know. And also remember, when you're talking about tropical cyclones, you must be able to figure out the naming of the tropical cyclones. Our tropical cyclones are named alphabetically. That is also another basic fact that you must note. This is tropical cyclone Becky, starting with letter B. It means it's the second tropical cyclone in that particular season. So our tropical cyclones, remember, they are named in alphabet in a given season, which means when a tropical cyclone is realized, it's named A, the first one in a season, and then the second one is named B, The next one is named starting with letter C, starting with letter D. So you can also get a question which asks you about the number of tropical cyclones that would have been realized in that particular season. You must be able to figure out that by looking at the first letter of the name of that particular tropical cyclone is also another geographical aspect that must be at your disposal. That is also going to assist you. And also, if you check these weather systems, they are given different names in different geographical spaces. Here in Southern Africa, we mainly call them tropical cyclones. And also, if you check in places around Asia, they call them the typhoons. And also, if you check the Americans, they call them the hurricanes. But basically, it's one and the same weather system. And also, what you must note is the movement direction of tropical cyclones. Remember, our tropical cyclones, they originate over the warm oceans. They need warmer temperatures for them to form. So our tropical cyclones in the Southern African region, they form over the Indian Ocean. And their movement direction, they move from the east to the west. So they start from the further east and they move towards the west. So we can say they move westwards. Thus, the movement of tropical cyclones, that is the other thing that you must also note. And the other important aspect also that you must note there is the conditions which are necessary for the formation of tropical cyclones. We say they need to form over warm ocean currents, and also we indicated that they need minimal friction, and also they need aspects like convergence close to the ground, and they need divergence in the upper atmosphere for them to effectively form. And also they require light variable winds for them to form. That is basic information that you must have. And also tracking the path of the tropical cyclone, if you can read from what is indicated there, according to the dates and the wind speeds, you can be able to figure out when the tropical cyclone was still in its formative stages and when it matured and then when it dissipated. You can see by the intensity indicated by the speeds of the wind. Where it reaches maximum, it means the tropical cyclone would have matured, where it causes more destruction. So if you check the data against the speed, you can actually see when it intensified and when it weakened and where it was during its time of weakening. Remember, the tropical cyclone will weaken as it gets inland. If it is still over the ocean, it will strengthen. For example, along the Mozambican channel, it will strengthen because there's more moisture which is being fed into the system. There's release of latent heat and there's very high evaporation that will be taking place. So it will strengthen because of those factors. And as it gets inland, remember, there is less moisture over the land surface and also there's friction which is going to affect the movement of the weather system. It weakens. So basically, those are the ideas that you must have. Then you must also be able to analyze the impacts of the tropical cyclones, whether on the environment, on the physical environment, or on infrastructure, or on social life of people, or on the economy. You must be able to figure out the effects of those weather systems. And besides you figuring out the impacts, you must be also be in a position to give suggestions on possible strategies that can be put in place to reduce the impacts of such weather elements. That is basically the idea that you must have when you are attempting questions on tropical cyclones, right? But that besides the point, that was just a discussion to enlighten you on what you must focus on. Let's go to our questions. We're not going to go through the text. We're just going to try to attempt the questions and try to give possible responses. What is the general direction of movement of tropical cyclones? We have just mentioned it. Our tropical cyclones, they move westwards. Westwards, or you can say they move from east to west. It's one and the same thing. Westwards and east to west is one and the same thing. State two conditions necessary for the formation of tropical cyclones. We have been talking about that. The conditions, they need sea surface temperatures, which are around 26.5 degrees Celsius. It's a requirement. They also need warm oceans where there's low pressure. And also we can mention that they need sufficient moisture. It's a requirement. There must be sufficient moisture to be fed to the system so that it strengthens, which results in the release of latent heat. It's a very critical factor, the release of latent heat. And we are also looking at other conditions like surface convergence. Air must converge on the surface. And what must happen in the upper atmosphere? There must be upper air divergence such that the system continues. Right. So that is the basics of the formation of tropical cyclones. Then moving on to number 2-3, give one reason why tropical cyclone be weakened from the 18th of November. Right. If we check on the infographic here, the wind speed, it was between 185 to 240 kilometers per hour on the 11th. But on the 18th, we are seeing that the wind speed reduced to around 110 to 185 kilometers per hour. Then on the 19th, we are seeing that it was less than 110, which means this system was weakening. So one reason why tropical cyclone weakened along those dates. Right. If also we want to check here, check its location. Right. This is the 18th. Unfortunately, our infographic is not very clear. We cannot clearly see, but let's justify why it weakened. If you see a tropical cyclone weakening, there are factors that would have contributed towards the weakening of it. Right. The first reason there, you can talk of limited moisture. If the system is lacking moisture, it is going to weaken. It needs more moisture to be fed, and that moisture must lead to the release of latent heat. So if there is less latent heat being released, the system is going to weaken. So it can be a possible reason that there was less moisture for the weather system. And also, most importantly, we talk about friction over the land. If the weather system is moving over the land, automatically it means it's going to be affected by frictional drag, and it is going to weaken. And also, we can talk of high pressure. Remember, this is a low pressure weather system. If it goes to areas with higher pressure, for example, if it reaches places which are cold, it is going to weaken because of the changes in pressure. Changes in pressure are going to affect the strength of the weather system. It is going to weaken. Right. We move on to the next question. Discuss the social and environmental impacts associated with the tropical cyclone Becky. Right, what you must note here, your question is specific. You must address either side. This is a balanced question. It needs a social and environmental, which means for a 2x2 response question, you cannot give two answers for social only and expect to get 4 marks because your response is not balanced. You must at least address one social and one environmental. So be also specific and be able to know which one is social and which one is environmental. Social, we are looking at the way of life of people, how the society lives, how are people going to be affected as a society. And environmental, we are looking at the surroundings. How are they going to be affected? So social, you look at things like the coming of tropical cyclone is going to cause floods. And how are those floods going to affect people? The floods are going to cause problems like waterborne diseases for the people. There will be a typical problem of waterborne diseases, which comes with flooding. The water systems are going to be affected, and people will end up consuming contaminated water. And for the same reason, people are going to experience the typical problem of waterborne diseases. You can talk of examples of waterborne diseases like cholera, typhoid. People are going to be affected by those diseases, right? You can also look at the social life of people in terms of how people are going to be affected. There's going to be disruptions in the way of life of people. Disruptions on movement of people, on business, on transportation. There are going to be so many disruptions there in the social life of people. Disruptions in terms of businesses of people or their daily activities. They're going to be disrupted. The transport system is going to be affected, which means people cannot effectively move because of the damage that would have been caused by the tropical cyclone. So you address the problem to the way of life of people as social. Then environmental, you're looking at the natural surroundings. Right, you can look at aspects like heavy rainfall, which could cause flooding. It's a negative implication on the environment. And also you can look at other problems like landslides. We can also experience problems of landslides because of excessive rainfall. Then we can also look at soil erosion. Soil erosion worsens because of excessive heavy rainfall. So basically, we can also look at other things like the disruption of the ecosystem is going to be affected. The biodiversity is going to be affected. So those are environmental aspects that you need to address. So what I urge you to do is, if you are attempting such a typical question, which is specific, can you also address the two sides of the story? Address social and address environmental. Right, we move on to the next question. Suggest two strategies that the local government could implement to minimize the impact of tropical cyclones. There are lots of things that can be done there by the local government. Do not try to force yourself to think from the textbook or try to force yourself to think how things are done from the textbook. You must be able to think outside the box. Take as if you are the responsible authority. You are the responsible authority in the area which has been affected. What can you do today to solve the problem? And what can you do for the sake of the future? Think outside the box and think openly so that you come out with feasible solutions. We want feasible strategies, something which is attainable, something which is within the reach of the local government. So you can talk of things like, in this instance, talk of early warning systems. They must be in place. People must be warned before the weather system affects. So people must be alerted through the different means. You can talk of the media, different avenues of social media. You can talk of the radio, you can talk of the television. People must be warned earlier on. And also you can talk of other things like evacuation of people in low-lying areas. Evacuate those people who are in areas which are prone to the problem of flooding. And also you must have aspects like emergency services must be in place. For example, ambulances must always be in place so that you can assist people who are affected. And also you can talk of emergency supplies. Supplies, for example, of water, they must be in place, or food. They must be put in place. Right. Then we can also talk of other things like shelter. There must be emergency shelter to house people who will be evacuated. They need somewhere to settle. So basically, you do not need to be hard on yourself, trying to think deeply. Think of things which are feasible, things which can be done, things which are within reach, which can be attained. That is basically what is required there. Right. That takes us to the end of the second part. Let's go to the third part. Refer to the figure below, which shows the urban heat island. I will basically explain. Then we'll answer the questions. We're talking about an urban heat island. Urban heat island, we are saying this is an urban area and the surrounding is rural. So when we're talking of an urban heat island, we are saying it's an urban area whose temperature is higher compared to the surrounding rural areas. You tend to find that the temperature here will be higher in the urban area as you compare it to the surrounding rural areas. That is an urban heat island. An urban area whose temperature is higher compared to the surrounding rural areas. Right. What causes the urban area to have higher temperatures compared to the surroundings? There are so many factors there which contribute towards the attainment of higher temperatures. Think of the buildings in the urban area, the built up area. Talk about the infrastructure like the roads, the pavements. All those factors, they contribute towards the absorption of heat. And as a result, we have higher temperatures. Talk about the traffic in the urban area. Talk about all surfaces, mainly in urban areas, they are artificial surfaces. They are just few natural surfaces. And also talk about the vegetation in the urban area is limited compared to the surrounding rural areas. So for those reasons, we tend to find that there are more factors that contribute towards absorption of heat in the urban area. And as a result, the urban area gets higher temperatures compared to the surrounding rural area. And why do the rural areas have relatively lower temperatures? It's because of the natural surfaces. We have the natural surfaces which reflect heat. We also have vegetation, which has a cooling effect. And we have water bodies in the rural areas, which also have a cooling effect. So that is the other side of the rural area. And then you must also be able to figure out what can be done to try and minimize the impacts of these urban heat islands. What must we do? Must we ignore the problem in an urban area that people are experiencing these high temperatures? Because remember, they come with consequences. They are typical problems that we can experience in the urban area because of the excessively high temperatures. We talk of things like heat strokes, excessive dehydration that causes a number of problems. So we need to devise solutions to try and reduce the average temperatures in the urban area. What must we do? Remember, we can talk of recreational parks where we introduce vegetation, where we introduce water bodies. Those ones will help to reduce the accumulation of higher temperatures within the urban areas. You talk of aspects like the usage of public transportation to reduce the volume of traffic on the roads. Remember, the traffic emits gases which are responsible for the absorption of heat. Talk of reflective surfaces. Instead of us painting the pavements black or painting with dark colors, let's use lighter colors which are reflective so that the amount of heat which is absorbed is minimal. That besides the point, that was just a discussion about the urban heat island. Our focus is to try and answer the questions. Let's go to our questions. Define the concept urban heat island. I think we've explained that. We are looking at higher temperatures, over the city. Compared to the surrounding. Our aspect here is the comparison. The urban area has got higher temperature and the rural area has got a lower temperature. That is an urban heat island. What is the difference in temperature between area labeled A and B? Right, our area labeled A, you can see our area A is here and our area B is there. What is the difference in temperature? We just need to note the temperature of B and the temperature of A. At B, you can see that the temperature there is reading 34 degrees Celsius. And area labeled A, you can see from here, it's around 24 degrees Celsius. 24 degrees Celsius. So what is the difference there? 34 minus 24 degrees, which give us 10 degrees Celsius. It's most important to put your units of measurement. We cannot just ignore the units of measurements. Our temperature, remember, we measure it in degrees Celsius. So you must also incorporate the unit of measurement of the variable in question. Right, that takes us to the next question. Our next question is Evaluate the impact that vegetation have on the temperatures of areas labeled A and B. What impact that vegetation? Evaluate the impact of vegetation over areas labeled A and an area labeled B. Right, if we look at A, there's more vegetation here. There's more vegetation cover. It's a rural area far away from the CBD. But if you look at the CBD here, there is no evidence of vegetation there. It means it's very minimal. So what is going to happen to the temperature? Remember, there is a relationship there between the vegetation and the temperature. Here, it's vegetated. So because of the vegetation, there's going to be lower temperatures. There is more vegetation. Here, there is less to no vegetation. It's less vegetated, that area. So for the reason that there's no vegetation, it is going to cause higher temperature. What is the significance of vegetation towards temperature? Remember, vegetation produces shade, and shade has got a cooling effect. We get cooled under the shade. So because of the shade, which is produced by the vegetation, the temperatures will be lower. And for the same reason that trees transpire through their leaves, they add moisture into the atmosphere, which is also a cooling effect, which reduces the intensity of the temperature. So where there's more vegetation, the temperatures will be moderate. But where there's no vegetation, it means that area is going to be having high temperatures. Right, that takes us to the next question. Suggest 2 strategies that can be implemented to reduce the effects of urban heat island. What can we do to reduce the effect of urban heat island? Automatically, we need more trees. The more we plant trees in the urban area, it means we are also contributing towards reduction of temperatures. Then we can also look at use of reflective building material and paintings. If we use material that are reflective, it will add to a positive impact. What else can we do? We can also develop water features. Water features, like we can have swimming pools in the urban area. We can also have water recreational facilities in the urban area. It is going to lessen the number of the amount of temperature which is going to accumulate over the urban area. We can also talk of things like reducing the number of the volume of traffic. Traffic volume reduction. How can we reduce the volume of traffic? Encourage people to use public transport. If we use more public transport, it means we are going to have less volume on the roads. A bus can carry 60 passengers. But if those passengers are using their own vehicles, we'll be having 60 vehicles on the road. So it means we are reducing the volume of traffic by using public transportation. Or if you can use the train, a train can carry thousands of people, which means if those people are driving their own vehicles, there will be large volumes of traffic which are going to emit more gases into the atmosphere, which are going to absorb more heat and contribute towards the rise of the urban temperatures. Right, so we can think along those lines. You don't need to be hard on yourself, just need to think lightly of what can be done. You can also look at industrial decentralization. It's also another strategy. We can decentralize industries so that we do not have high volumes of pollution into the atmosphere, which is going to absorb heat. Right, there are so many strategies that we can talk about. We can talk of other things which are not mentioned here, but we're not saying that is all. Right, so the next question is focused on geomorphology. We're going to discuss just few aspects here on geomorphology. Right, I'm just going to explain quickly on the first part before we answer the question. This is a reverse longitudinal profile on the extreme left, and we also have the reverse transverse or cross profile. Right, what is the distinction between these two? Longitudinal profile of a river, it shows the shape of the river from the source where the river starts to the mouth where the river ends. So our river is divided into three phases or into three stages of development. We have the first part, which is the upper course, and then as the river progresses, it reaches what is called the middle course, and then it reaches the lower course. Or in another dimension of understanding, the river is in its youthful stage. Here it's still young, it's in the youthful stage, then it reaches maturity, then it gets old as it gets to the last part. Right, that is our longitudinal profile. And then we have a transverse. A transverse, it shows us the shape of the river from one bank to the opposite bank. So it's a cut across within the river channel. How does the river channel look like if we are to cut across it from one bank to the other extreme bank on the other side? How does the river channel look like? So we can see that at A, this river is plus or minus having a V-shaped valley, and the volume of water you can see is minimal. And you can see that the same river is now wider. At B, is now having a wider, and also the volume of water is increased. And if you check as it goes towards C, this river is now very wide and is now shallow. And also if you check the volume of water now is more. That's basically the cross profile. Right. Let's answer the questions. Number 2.1.1, it says, this course of the river is characterized by steep gradient and a V-shaped valley. Steep gradient, you can see here, this river is very steep on the longitudinal profile. And also if you check at A, this is a V-shaped. What does that happen? It happens in the upper course. So the upper course, that is where we have those features. The volume of water in the upper course is, what did we say? The volume of water you can see there. This is the upper course. This is just little. It's low. Fluvial landform in the lower course that encourages farming is. Farming is done on the flat plain, the flat area which is adjacent to the river. Right, the area drained by a river and its tributaries is known as, that is a drainage basin. The dominant stream discharge associated with the transverse profile C. The dominant stream discharge associated with the transverse profile of C. Here, what kind of discharge? Is it turbulent or laminar? Basically, it's laminar. There is going to be a steady flow of the water. The water will flow smoothly. Right. Temporary base levels of erosion are evident or shown in. Where do we find temporary base levels? We see them on the longitudinal profile. Right. We move on to the next question. The next question is based on infographic about on the Tugela River drainage density. Right, it talks about the origin over the Drakensberg, the mouth in the Indian Ocean, the length, which is about 560 kilometers, and the area of drainage basin is around 29,100 square kilometers, and tributaries, the major ones, is Buffalo River and Moi River. Right, that is the infographic that we have for Tugela or Utukela River. Right, define the concept drainage density. Right, what you need to note here when you're looking at density, we can simplify. I want to simplify this. You will derive geographical sense. Right, we can define density as the total length of streams in a drainage basin. Or we can look at it as the total number of streams. That's density. What am I saying here? Let me say there's river A, then there's river B. River A, the main river, is like that. And it has got some tributaries and sub-tributaries like that. That is river A. Is drainage basin A. And drainage basin B, the main river is there. And it's like this. If you're comparing these two in terms of density, we are saying which one between the two has got many streams. If you have to look at numbers, we look at the cumulative numbers of streams. You can see that there are many here. So this is a high density drainage basin. This basin has got high density. But if you look at this, if you look at the number of streams, you can see that the streams are just few. So it's lower density. So we can look at it from the dimension of the number of streams, or we can look at it from the dimension of the length of the streams. What are we saying? If we were to add up these streams here into one, how long will they be? Automatically, this is going to be a shorter length compared to this. If we add up all these streams to make them one, we'll find that the cumulative length of these streams is going to give us a very longer stretch. So that is density. We are looking at basically the number of streams or the cumulative length of the streams in a drainage basin. Thank you. Right, we move on to the next question. Compare drainage density of Tugela Basin area A and area B. We are basically comparing. If you check area A here, and then area B, automatically here there is a high density. A has got high density. There are many streams here if you check, but here is very low. So area A has got high density, whilst area B, the density is low. Right. Next question is saying, compare the drainage. We are done with that one. In a paragraph of approximately 8 lines, discuss the factors that affect the drainage density of the Tugela River at area B. Right, I will try to simplify this. There is another question which we are going to look at, which is almost the same as this. So I'm not going to discuss again the same thing. I'm just going to highlight the question and we are going to see. Right, we want to look at factors that affect the drainage density at area B. So our focus here is, we said we have areas that have got high density and areas that have got low density. So in our case, our area B is low density. Then there are areas which have got high density. I want us to distinguish between these two and explain what contributes towards high density and what contributes towards low density. Right. What you need to look at here, the factors that result in development of streams, they are mainly two factors there. Right. Is the amount of, one, surface runoff, and number two, the level of infiltration. These two, you need to look at it from the dimension of factors that promote surface runoff. If there is more surface runoff, more streams are going to develop. And it means that area will have a high density. So you need to look at factors that contribute towards increased surface runoff. And for the same reason, again, is the opposite with infiltration. It means the area must also be having typical problems with infiltration. There must be less infiltration. There must be more surface runoff and less infiltration for us to have high drainage density. Then for low drainage density is the opposite. There is less surface runoff and there is more infiltration. What am I saying here? Low density, you are saying there are fewer numbers of streams in the drainage basin. What contributes towards the reduction or the non-availability of a variety of streams in a given area is the rainwater is finding its way into groundwater storage. It's infiltrating and percolating into groundwater storage. It is not finding an opportunity to flow over the surface to cause the development of more streams on the surface. And at the end, we end up having fewer numbers of streams over the surface. So for that reason, we are saying, what factors can contribute towards high surface runoff? Look at aspects like the gradient of the area. Areas which are steep, they have got more streams. Why? Because the rainwater does not find an opportunity to infiltrate because of the nature of the steepness. It's very steep, and hence the rainwater is going to flow over the surface, forming a number of streams. And for the same reason here, if it's low density, it means there must be general gradient. General gradient allows for water to infiltrate into the ground, and hence there won't be many streams forming. If you look at here, this is basically around the Drakensberg area. This area is steep sloping, where we have so many streams. And as we go down towards the Indian Ocean, automatically it means there is general gradient approaching the ocean. So rainwater here will infiltrate because the ground is gentle. But here, we are around the Drakensberg area, there's steep gradient. There are more streams that are going to form there because of the nature of the steepness of the area. Right, that is one physical point that you can talk about. Then you also need to look at other aspects like vegetation. How does vegetation contribute towards? Where there's less vegetation, it means there will be more surface runoff. And where there's more vegetation, it means there will be more infiltration. The vegetation roots are responsible for loosening the soil to allow for infiltration. So where there's more vegetation, it means that area is going to have more infiltration and less surface runoff, hence less streams are going to develop. Then you also look at other aspects like the amount of groundwater, the moisture in the ground. Areas that are usually wet, they have got more streams because the ground is saturated. But areas which are dry, they will have less streams because the moisture will be allowed to add to ground moisture, and hence we will have less of streams forming. Then we also look at other aspects like permeability. High drainage density, it happens in less permeable, the underlying rocks. If they are less permeable, it means there will be more streams. They don't allow for the seeping of water into groundwater. And if there is more permeable rocks, the rocks are permeable, they allow for water to filter into the ground. There will be less streams. And also look at the porosity of the soil. Pore spaces. If the soil is more porous, it has more spaces, it allows for more infiltration. There will be less streams. But if there's less porosity, the soils are compacted. It will also mean that the rainwater cannot infiltrate into the ground. So that is basically what you focus on. Focus on aspects of surface runoff and focus on aspects of infiltration. That will guide you towards answering that particular question. Right, that takes us to 2.3. 2.3 is referred to a figure below showing a fluvial landform. I'm not going to explain much on that. This is a meander, and we understand a meander with time, it is going to develop into an oxbow lake. And apparently, if the oxbow lake dries up, it becomes a meander scar. That is common geographical knowledge. We don't need to spend much time on that. Identify the fluvial landform shown in the figure. That is a meander. We've talked about that. A meander basically is a bend along the river channel. So we have indicated that it's a meander for that reason. In which course, upper course or lower course of the river, will we have the above landform? It forms in the lower course. We cannot have meanders in the upper course. Typical landforms in the upper course are rapids, the gorges, the waterfalls, V-shaped valleys, because of high rates of erosion. because of the nature of steepness of the landscape in the upper coast. But as we go to the lower coast, the ground becomes gentle. The river starts to wind as it tries to identify and locate areas of weaknesses to flow. Right, we move to the next question. What is the dominant process taking place at the outer bank? Right, these two banks, Bank A and Bank B, this is the outer and this is the inner. On the inner, there's deposition, there's less velocity, the water flows slower, and there's more deposition. On the outer, the water flows faster, and there is erosion. So those are the two processes. So it's erosion on the outer. Right, draw a labeled cross-section of line AB. Right, A we said is the inner and B is the outer. Inner there's deposition and outer there is. So you draw your A, you draw your B. How does the river look like? It's gentle on this side because there's deposition. How is it going to look like as we go towards B? It's going to be steep. So the shape of the river looks like something like this. Such that here we call this a slip of slope, and this is called an undercut slope. So that is basically the shape of the river. It must be gentle from A, which is the slip off because of deposition, and it must be very steep because of undercutting. That is why the meander will migrate. It will migrate in this direction because there is erosion taking place here, and this river will keep on, this river channel will keep on migrating in that direction. Discuss the influence of fluvial landform above on human activities. The meander, how is it influential over human activities? We can talk of fertile soils for farming. It can avail fertile soils for agriculture, which is a positive impact on human, and also recreational activities. Possible. You can also look at water for domestic or commercial use. For use or for farming. You can also look at flatland for human settlement. It avails flatland where you can settle. So that is basically what you focus on. And then if you also look at this side, it's not conducive for settlement. Why? Because there is erosion which is going to take place. But if you look at the side of A, it's very safe for settlement because there's deposition there, and there's also chances of fertile soils because of the deposited material. Right, that is basically what you look at. Right, there is some additional question on geomorphology that I want to discuss also after this. Just a few aspects. We discussed about drainage density. It's basically the same thing that we have discussed earlier on. We don't need to waste time repeating the same thing. Area A against area B. If you are to look at drainage density there, we talked about the definition of density. We said we define it as the number or as the length. So you can see that's the definition that we can use. Right. Which of the drainage basin A or B shows drainage density during dry season? Right, during the dry season, what is going to happen there? During the dry season, we have typical problems of loss of moisture on the ground, and it means some of the streams, they are going to dry up. So we'll be having only the main streams. These other tributaries, which are small during the dry season, they dry up, and only the major rivers will sustain and will keep on flowing. So basically, it's B in this instance. Support your answer. For that reason, we are saying our answer, we support it by the fact that A has got more tributaries or more streams. So B, in this instance, if we look at B, the number of streams or the length of streams is now limited. And for that sake, it shows that this area here is the one that is most likely to be the drainage density during the dry season because of the less density of the streams. During the dry season, most streams, they dry up, and hence the drainage density will reduce. We have less streams. So if you are comparing those two, you tend to find that B is the one which has got the typical conditions of a dry season. Name the underlying rock structure where the stream pattern in A forms the underlying rock structure. Right, this is a dendritic pattern. Where does dendritic form? It forms in areas that have got uniform resistance. Areas of uniform, they are uniformly resistant rocks to erosion. What is the characteristics of the stream pattern in figure A? What's the feature of stream pattern? If you look at this is dendritic, and where does the word dendritic originate from? Is from dendros. And what's the meaning of dendros? It means a tree and its branches. So if you check the nature of this drainage pattern here, it resembles a tree and its branches. So that is basically how you can describe the nature of the pattern there. Describe 3 factors that may have resulted to the drainage density at B. 3 factors that may have resulted in lower density. We've talked about that. Factors that contribute towards lower density. Talk of aspects, like in some areas, look at the amount of rainfall. A dry area which has less rainfall, which receives less rainfall, we are likely to have less density. Talk about the gradient, like what we mentioned earlier on. Talk about the porosity, talk about the permeability, talk about the steepness of the area, talk about all those aspects. You look at them from that perspective. Look at the soil moisture, look at vegetation in the area. We mentioned all those things. We cannot repeat the same thing. Right. That takes us to the next question. We are just also going to discuss a question on climate and weather, which is a synoptic weather map. By merely studying our synoptic weather maps, we must be able to figure out aspects. I'll just highlight critical aspects that you must note there. You must be able to figure out the weather systems, be able to identify the pressure systems, and be able to figure out the season being depicted there. Yes. For example, and also you must be able to figure out the intervals, the isobaric intervals, though that is basic knowledge that you must have. Weather systems, we are saying there are specific weather systems that you must note. For example, we have mid-latitude cyclones, we have tropical cyclones. You must be able to identify them on the synoptic map. The pressure systems, we have typical anticyclones, the South Indian, the South Atlantic, the Kalahari high pressure cell. You must be able to figure out them and be able to see their location and the implication of their location. Be able to also to figure out the low pressure systems. We have the coastal low pressure. We also have the thermal low pressure over the interior. Be able to figure them out. Then be able to also figure the seasons on the synoptic map based on what is shown on the basic map. The location of the pressure systems. They give you a clue on the season being depicted. The weather conditions prevailing over given spaces. They also give you a clue. Clues like the date of the synoptic map, the weather systems that are prevailing over that area, they give you a clue about the season in question. Right, then you also look at the interval, which will also going to help you figuring out the high pressure and the low pressure, and also in some moments figuring out atmospheric pressures of isobars which are not indicated. Right, that is basic understanding of the synoptic map. Right, let's go to our question. Identify the high pressure cells labeled E and F. Right, we see our E is here and our F is here. There's a high pressure cell here and a high pressure cell here. This is the Southern African subcontinent, like what you can see there. So it means this is our west and this is our east. So automatically on the east, we have the Indian Ocean, and on the west is the Atlantic. So our anticyclones, automatically this becomes the South Atlantic high pressure cell, and this becomes the South Indian high pressure cell. Those are our two anticyclones. This synoptic map depicts summer or winter conditions. This is a synoptic map for winter. Provide two pieces of evidence. The pieces of evidence that we have here, the location of these anticyclones. In winter, they are located further to the north. Look at where they are. They are adjacent to land here. They are adjacent to land. They are latitudinally located adjacent to land. So they are further to the north, which happens in winter. That is evidence number one. The other evidence is this, the coming of the mid-latitude cyclone over the Western Cape here. This happens in winter. The mid-latitude cyclone, you see the cold front here, is approaching the Western Cape of South Africa, which is typically a condition which is experienced during the winter season. And if you also look at yeah, that is those pieces of evidence. There's no date, unfortunately. If there was also a date, you also substantiate using the date. So you look at mid-latitude cyclones prevailing, you look at the cold front which is approaching, and also look at the position of the high pressure cells. Right. Describe the circulation of the air at the weather system marked G. Let's look at the weather system marked G. Right. If we look there, it suggests our circulation. It says suggests the circulation of the weather system marked G. Our weather system in question here is this our mid-latitude cyclone. How does air circulate within the mid-latitude cyclone? This is a low pressure cell, and a low pressure cell in the southern hemisphere, our circulation is always clockwise. Do not forget that. Is always clockwise. So it's clockwise circulation for a low pressure cell. So a low pressure weather system, it has clockwise circulation. That is in the southern hemisphere. And a high pressure and anticyclone, it has an anti-clockwise circulation in the southern hemisphere. The opposite is true in the northern hemisphere. A low pressure cell, it circulates anti-clockwise in the northern hemisphere and clockwise for a high pressure cell in the north. So it's the opposite. What happens in the southern hemisphere is reversed in the northern hemisphere. Right. That besides our point. 156, it says, the common wind associated with the weather system marked G. Let's look at the weather system marked G. What kind of weather system associated? This is a coastal low. See a low pressure here. For the same reason, this is a coastal low. What is happening with the coastal low? Coastal low, remember, we said they move from the western coast to the eastern coast. And they are the ones which are responsible. If there is a coastal low pressure, it creates pressure gradient between the interior and the coastal areas, such that winds are driven from the interior being fed to the coastal areas, and that is going to result in the berg winds. That is associated with the coastal low. They result in the formation of the berg winds. Right. Identify the weather system marked H. Unfortunately, our marking is not very clear. Our H is here for this weather system. That weather system is a mid-latitude cyclone. Mid-latitude cyclone or a frontal depression. Then our last question, it says, explain how a warm front occlusion can occur as the next stage of development of this mid-latitude cyclone. Right, when you're explaining a warm front occlusion, when you're looking at an occlusion, we are saying, I'll just try to explain and try to simplify the occlusion. When an occlusion happens, remember, we have a cold front and we have a warm front, like this. And our weather system, this is our cold front, and this is our warm front. And remember, our weather system, it moves from west to the east. So for the reason that there is cold air here, and there is warm air here, and this is cold air again. So the cold front moves faster, this one. Why does it move faster? Because it's more denser and it's pushing towards less dense air. Warm air is less dense, so it moves faster. But the warm front does not move faster because it's warm air which is advancing towards cold air which is more denser. So for that reason, we have the cold front advancing faster. What is going to happen if the cold front advances faster? It is ultimately going to catch up with the warm air. So if it catches up, it means it's only cold air which is now occupying the ground, and the warm air has been uplifted. It has been forced to rise because of the undercutting which has been caused by warm air. This is a stage that we call occlusion. If this happens now, we have reached a stage of occlusion. And our occlusions, remember, they come in two dimensions. There's what is called a cold front occlusion. Then there is what is called a warm front occlusion. The only difference here in the indication is that the cold front occlusion, you check, this is our ground. In a cold front occlusion, the cold air is undercut the warm front. The warm front is there and the cold front is here. The cold front is the one that touches the ground on this part. Cold air will undercut warm air, and then it means in that instance, there is an undercutting of cold air. This is cold air, and this is cold air ahead. So it automatically means on this area here, the warm air has been displaced completely. It's now only in the upper atmosphere. And then the warm front occlusion, the difference here is the warm front from this side is the one that touches the ground, and the cold front will be on top like this. The difference here is about the temperatures of the air that we have. We have in this instance cold air and cool air. That is the distinction there. This cool air is trying to advance towards the cold air. But however, because this one is more denser than this one, this is cool, this is cold. The difference there. Both of them, they are slightly cold, but the temperatures are different. This one is slightly cold, but this one is very cold. So for the reason this one is more denser than this, so it cannot effectively undercut the cold. So the warm front is the one that continues to touch the ground. This is a warm front occlusion. So basically, when we're looking at occlusions, we are looking at when the cold front would have caught up with the warm front, and there is complete displacement of warm air close to the ground. And for that reason, we have a situation of the warm air being permanently displaced from the ground. Right, that takes us to the end of our discussion. I hope this is going to assist you in preparing for your March tests, and also to take you a long way to prepare for your paper 1 theory, question number 1, and question number 2, climate and weather, question number 1, and question number 2, geomorphology. We are going to meet in other discussions to follow. Stay tuned to your host in geography. Thank you.
Welcome to Thundereduc, an online learning platform powered by professional, highly skilled and qualified educators.
We deliver structured CAPS online lessons for high school subjects including mathematics, physical sciences, life sciences, geography, business studies, history, accounting, English, Afrikaans, and others.
For the intermediate and senior phases, we offer expert teaching in natural sciences, mathematics, social sciences, English, and EMS, designed to build strong academic foundations.
Access the distinction material books by clicking join button on our YouTube channel, or download Thundereduc app on Google Play Store for all our study material and past exam papers.
Thundereduc offers extra classes for rewrites, old curriculum, and other students from grade 4 to grade 12 through online and physical classes.
Subscribe to our YouTube channel, Thundereduc, for reliable curriculum-focused learning, and stay updated with the latest educational content.
Please like, share, and turn on notifications so you never miss a lesson.
Visit us at www.thundereduc.com
Or call 0786 636 613 or 084 833 1738 for more details.
Thundereduc. We focus on quality.